Hello viewers, in today's session we are going to discuss another important problem from three-dimensional geometry, and here we are going to find out the equation of a plane which passes through this point, that is 4 comma 7 comma minus 7, and the plane contains this line whose equation is x plus 1 over minus 2 is equal to y minus 3 over 3 is equal to z plus 2 over 1. So here the equation of the line is given in symmetric form, right? So let us see how we can find out the equation of the plane where we are given two conditions, that is the plane passes through this point and the plane contains this line. So let us first draw a rough diagram. Suppose this is the plane whose equation is to be obtained. Now this plane may be denoted by the letter pi, and here this plane pi, it contains this point, that is 4 comma 7 comma minus 7, and this plane contains this line. Now see, this line passes through the point that is minus 1, 3 and minus 2, because here we can write the equation of the line like this, that is x minus minus 1 over minus 2, y minus 3 over 3, and z minus minus 2 over 1. See here the equation of a line in symmetric form may be written as x minus x1 over a, y minus y1 over b, and z minus z1 over c. So whenever we are given the equation of a line in this form, then the line passes through this point, that is x1 y1 z1, and the direction ratios of the line are given by A, B and C. So if we compare this line with this one, then x1 is minus 1, y1 is 3 and z1 is minus 2. So this line passes through this point, minus 1, 3 and minus 2. So let us denote this line by the letter L. So here we have the line L, and since this line L passes through this point, so this point also lies on this plane, that is minus 1, 3 and minus 2. So now we have 2 points lying on this plane pi. So now we can easily write the equation of the plane pi like this, that is a times x minus say x1 plus b times y minus y1 plus c times z minus z1 is equal to 0. So the equation of any plane which passes through a point x1 y1 z1, the equation of the plane can be written like this, where capital A, B and C are the direction ratios of the normal vector, say n, are given by A, B and C. So here we have the normal vector like this. So this denotes the normal vector. Now this plane pi contains this line L, therefore this normal vector is perpendicular to this line L, that is vector n is perpendicular to the line L. So now this plane pi passes through these 2 points. So these 2 points must satisfy this equation. So let us first take this point. So substituting this point in this equation, we can now write the equation of the plane pi as a, and here we have x, and x1 is minus 1. So here we have plus 1 minus minus plus, then we have b times y minus y1. Y1 is 3. And then we have c and z minus z1. Z1 is minus 2. So here we have plus 2. And this is equal to 0. Right? So let us call this equation as equation number 1. Now this plane also passes through this point 4 comma 7 comma minus 7. So let us substitute here for x, y and z as 4, 7 and minus 7. So we have here a, then we have 4 plus 1, then we have b, and y minus 3, y is 7, 7 minus 3, and then we have c, that is here we have c, and z is minus 7. So minus 7 plus 2 is equal to 0. So now we have an equation in a, b and c. So this is 4 plus 1 5. So here we have 5a. Then 7 minus 3 is 4. So we have 4b. And then 2 minus 7 is minus 5. So we have minus 5c is equal to 0. Right? So now using these 2 points and utilizing this equation, we have now obtained an equation in A, B, C. 5a plus 4b minus 5c is equal to 0. So now our aim is to get another equation in A, B and C using this condition, that is since this plane pi contains this line L, therefore the normal vector to this plane pi is also perpendicular to this line L. Now the direction ratios of the normal vector are A, B and C, and the direction ratios of this line L are given by minus 2, 3 and 1, right? And we know that when two vectors are perpendicular to each other, then we have this condition, that is say a1 a2 plus b1 b2 plus c1 c2 is equal to 0, where a1 b1 c1 are the direction ratios of the first vector, and a2 b2 and c2 are the direction ratios of the second vector, right? So here this normal vector n has the direction ratios A, B, C. So A1, B1, C1 may be taken as capital A, capital B, and capital C, and A2, B2, C2 may be taken as minus 2, 3, and 1. So, utilizing this condition for perpendicularity of two vectors, we can now write A times minus 2, then we have b times 3, and then we have c times 1 is equal to 0. So now we have here minus 2a, then we have 3b, and here we have c is equal to 0. So this is our equation number 3. So now we have obtained two equations in A, B and C, right? And now we have to solve these two equations. So now the usual practice to solve two equations in three variables is the cross multiplication method, but here I will prefer the elimination method. So we'll select any of the three variables here, and then we'll equate the coefficients of that selected variable, and then we'll eliminate the variable by either adding the equations or subtracting the equation. So let us here select this variable, that is variable c. So here we have minus 5c, and here we have simply c. So let us multiply this equation 3 by 5, so that the coefficients of c are equal in both these equations, right? So now multiplying equation 3 by 5, here we have minus 10a, then we have 15b, 5 times 3 is 15, and here we have 5c is equal to 0. So now here we have equation number 4. So now we'll eliminate the variable c from equation 2 and equation 4 by adding equation 2 and equation 4, right? So here when we add equation 2 and 4, then here we have 5a, here we have minus 10a. So 5 minus 10 is minus 5a, and here we have 4b, and here we have 15b. So 4 plus 15 is 19b, and here 5 minus 5c and plus 5c, so these two get cancelled, and this is equal to 0. So now we can write minus 5a is equal to minus 19b. Now negative and negative here get cancelled, and we have 5a is equal to 19b. Now let us introduce a scalar here, say lambda, where lambda is not equal to 0, and lambda belongs to the set of real numbers, right? So here we'll take 5a is equal to 19b is equal to lambda, and the purpose of introducing this scalar lambda is to express the values of a, b, and c in terms of lambda. So from here we can now write 5a is equal to lambda. So a is equal to lambda over 5, and from here we have 19b is equal to lambda, so b is lambda over 19. So now a and b are expressed in terms of lambda. So let us substitute the values of a and b either in equation 2 or equation 3 to get the value of c in terms of lambda. So here we'll substitute the values of a and b in equation number 3. So now we have minus 2a, a is lambda over 5, then we have 3b, so we have 3 lambda over 19, and plus c is equal to 0. So c is now 2 lambda over 5 minus 3 lambda over 19. So taking these two terms to the right hand side. So now here to get the value of c, we have to solve this expression, and here we can take the LCM. So we have the LCM of 5 and 19 as 95, and now taking the cross multiplication, we have 19 times 2 is 38, and then 5 times 3 is 15 lambda. So now 38 lambda minus 15 lambda is equal to 23 lambda over 95. So now the values of a, b, and c are expressed in terms of lambda. So now let us substitute the values of a, b, c in equation 1 to get the equation of this plane pi. So now we have here a is lambda over 5, then we have x plus 1, b is lambda over 19, and y minus 3, and then c is 23 lambda over 95, and here z plus 2 is equal to 0. So now here lambda appears in all these three terms, and lambda is not equal to 0. So we can now write lambda, and then we have 1 over 5 x plus 1, then we have 1 over 19 y minus 3, and then we have 23 over 95 and z plus 2, and here we have 0. So now this scalar lambda is not equal to 0. So this factor has to be equal to 0. So we have 1 over 5 x plus 1, then 1 over 19 y minus 3, and 23 over 95, and z plus 2 is equal to 0. So now let us multiply this equation throughout by 95, so that we can get rid of the denominators here. So now here we have 1 over 5 times 95. So 5 times 19 is the 95. So we have 19 times x plus 1, and here we have 19. So 19 times 5 is 95. So here we have 5 times y minus 3, and 95 and 95 get cancelled. So we have here a 23 times z plus 2 is equal to 0. So now simplifying this expression, we have now a 19x plus 19, then we have 5y minus 15, and then 23z plus 23 times 2 is 46, and this is equal to 0. So now we have here 19x, then we have plus 5y, and here we have 23z, and here we have 19 minus 15, 19 minus 15, and here we have plus 46. So 19 minus 15 is 4, and 4 plus 46 is 50. So here we have 50, and this is equal to 0. So this is the required equation of this plane pi in Cartesian form, right? So here the form is ax plus by plus cz plus d is equal to 0, because we know that any equation of this form in first degree, that is x, y, and z are in first degree. So ax plus by plus cz plus d is equal to 0. It always represents a plane. So the required equation of this plane, which passes through this point 4 comma 7 comma minus 7 and containing this line L, is given by 19x plus 5y plus 23z plus 50 is equal to 0. So viewers, this is how, by the application of the concept of direction ratios, we can find out the equation of any plane pi with these given conditions. And here it is important to note that the coefficients of x, y, and z gives us the direction ratios of the normal vector. So here the normal vector n has the direction ratios as the coefficients of x, y, and z, and here we have 19, and then we have 5, and here we have 23. So the direction ratios of the normal vector are 19 comma 5 comma 23, and the equation of the plane pi in this form is 19x plus 5y plus 23z plus 50 is equal to 0.